Hey, everybody, we're going to get started in just a second. Be right back. Thank you. All right. Hello, everybody, and welcome to our session today. Thank you for taking your time out of your day. This should be a pretty valuable session. I'm really, really happy to have my friend Adam Storm, my peer here at Cockroach Labs, join us. Adam's been in the database world for quite some time, and really kind of gets these topics inherently deeply. So we should have a pretty great conversation today. But before we get started, just wanted to do a little bit of housekeeping. We got a list of topics we're going to talk about here. We're going to talk about, the impact of the speed of light on data, on compute, of the way you design your applications. Some of the things that we've done here at Cockroach Labs to fight the speed of light, and just kind of what it means to be hitting physical limits of our world, and these kind of things. So I'm looking forward to the conversation. It'll be immediate to beginner. Nothing too deep. We aren't going to get into code, but we'll definitely have a pretty deep technical conversation. Please do ask questions in the QA and in the chat. And if you're on YouTube, which I know a lot of people join via that channel, I believe there's a way to ask questions there. And JP will help get them into our official chat and QA so we can answer them on this channel as well. So, but first of all, thank you all for joining. And then finally, the recording definitely will be available a little later today. Everybody asks. So before you ask, yes, absolutely. So again, thank you for joining. Adam, are you here with me? You're somewhere. There you are.
Yeah, I'm here.
Hey, Adam, how are you today?
I'm good. How are you?
I'm doing very well. So this conversation came about, y'all. This concept of the talking about the speed of light. We have a little bit of a funny internal joke here, and lucky I get to do these kind of onboarding sessions when people join Cockroach, and we talk about who we are in the market and the other database vendors and all these different things that are going on. It's a company where we kind of take heed of what's happening around us. And funny enough, we had one of our engineering managers get up one day and put a number up on a chalkboard on a overhead and ask people what it was, and it was the speed of light. And it's like that is the ultimate competitor to a lot of things that are going on here at Cockroach Labs, because I think we are definitely running into these limits of physics. And so Adam and I just wanted to have a conversation about what that means, what it means for data, what it means for our consumers and the people who are using our applications. But more importantly, what does it mean for you and your applications? And not just from the database point of view, from the way you think about architecting and coding and these sort of things you kind of put into things. So that's what our conversation is going to be today. So Adam, I would love to introduce you, but I think you can probably do this. You can probably do this best. So if you want to just give an introduction of you and your background and what you do here at Cockroach Labs.
Sure. Thanks for that great introduction on this topic. I think it's going to be a great webinar too. My name's Adam Storm. I'm a Senior Director of Engineering here at Cockroach Labs. I've spent my entire career basically thinking about data and databases. I spent about 20 years working at a competitor on their database technology. I joined Cockroach Labs about just a year and a half ago. And since I joined, I've been working in a bunch of different areas, one of which is our multi-region capabilities and how we improve them in 21.1, which we're going to talk about in a little bit. I also work on the team that manages our SQL front end and the team that manages our multi-tenant offering, which is exposed to customers through our serverless offering on the cloud.
That's great, Adam. And Adam, you've been building a database in some form or fashion for really quite some time. what led you to that piece of the stack, or like that as an, was it just dumb luck? Was it like you sought it out? Like, how did you get into databases, dude?
Yeah, I wish I had a really great story, but I don't. It was a lot of dumb luck. When I graduated, for people who know me, they know I'm really passionate about the city of Toronto, which is where I live and I grew up, and I wanted to get a job there. And at the time that I was looking for jobs, there was really like one big player in town in terms of software development jobs. This was like in 2000, which is like long before the Googles and the Facebooks and all the other companies, Shopify, came to town. And so I applied at that company. They had a job posting that they put on the job board at the university I went to. I applied, I got the job, and then they told me you're going to be working on the database team, and the rest is history.
And there you were, for years and years and years working on a database. And databases are not simple technology. I always say, Adam, let's like, look at, if databases were easy to build, we'd have a lot more. We already have a lot of them, I guess. I don't know. But if you look at like the pure, like sheer number of developers and the sheer number of applications, I mean, the number of, those tools that are out, or that our databases are small, because I think they're just difficult to build, right? I mean, what makes a database more challenging than another piece of software? And do you think?
Yeah. So it's a great question. And actually, I can tell you a little story that maybe will illuminate how difficult this question is to answer. So when I first joined the database team, I got together with some of my old colleagues from university, and they said, you're building a database, fine. Like, what? That's interesting and all. But like, how is it really any different than just using a single file on disk and having people write to that file? And I said, at the time, I couldn't really provide a compelling answer to that question, which embarrasses me to this day. But really, the answer is the differences between storing data on a single file on disk and controlling access to it versus a commercial relational database is immense. It's immense because commercial databases have the ability to store your data consistently, to allow multiple people to update data at the same time or near the same time and have consistent results, to see atomicity of the data that they're operating on, to ensure that if that file somehow gets corrupted, that you can recover from that corruption, to ensure that if you have more demand for updates to your database than a single server can provide, that you can scale the updates in a consistent way out to multiple servers. And all of this is, we haven't even touched on the fact that the data that lives in there, you're going to want to query in some way, and relational databases provide a means to do that in a way where you can construct very, very complex ways of analyzing that data easily.
Yeah, and it's all the ACID stuff. It's the relational model or whatever model you're using from a data model. I mean, all that is calculus ultimately in the end too. It's all math, right? So, and I just find it, the history of databases to me is always very compelling, because honestly, like I've said this before, I think, there's like a couple of our databases that have been around for like the 30 or 40 years, one that you worked on, you know what I mean? Those two or three, and Photoshop, I think, are the most insane, most beautiful pieces of software man has ever created. Like, our lives run in these things, right? Like, I mean, our banks, the nuclear codes, it runs on these databases. So yeah, it's not a file system. It's not a file. It is so complex, and they're amazing, honestly. And I think, kudos to any engineer who's been working in databases for a long time. Seems like kind of like mundane work. It's just simply not, dude. It is some of the most complex challenges there are. So I'm honored to work at Cockroach Labs, because I think we're doing some interesting things, because when you start to combine the database with distributed systems, Adam, you've been through this kind of shift in your own paradigm, right? In your own head over the last, what? How long have you been with Cockroach Labs, Adam?
About 18 months.
Yeah, a year and a half. So, I mean, when you landed at Cockroach and you start to think about distributed systems and speed in broadly, geographically distributed systems, how did things change for you? What were the big things?
Well, there's a lot that you need to sort of wrap your head around. I think the first is that you really need to wrap your head around everything is a consensus operation. And you need to understand that quorum is necessary to be achieved for write operations, maybe not for read operations, but quorum is a big thing that you need to kind of wrap your head around. And the placement of replicas to ensure quorum, and how many replicas, like what is a majority of replicas that need to be contacted. So that's one thing. And then you very quickly, it's interesting that you mentioned off the top that you get to talk to new hires, because I vividly remember in the first day that I worked here, you gave a talk about how the speed of light really is our biggest competitor. And very quickly, when you start looking at these multi-region problems, and when I say multi-region, I mean a database that spans more than one cloud service provider region or more than one geographic location, you really hit the speed of light hard very quickly. And we're going to talk a little bit more about that, but wrapping your head around the limitations of the speed of light, I think are something that you better realize pretty quickly, because if you don't, your distributed system is just not going to perform.
That's right. And if you're working on a database or you're working on an app, like literally flat out, like you have, these things come into consideration. It's like, I mean, it's like what the team at Google has been doing for the last 10 to 15 years. They've been solving these problems. And I think it's a lot of this technology comes out of those groups. It's like the inside the brain of Jeff Dean and Sanjay Gemawat. And we're all kind of living in that, and you start thinking about quorum, it's a single logical database running across multiple different places, multiple different physical locations, and that is truly tremendous. And so let's get into the speed of light. And so what are those challenges, Adam? Right? Because I think we see it day to day, and understanding what quorum is in that context. What are some of the biggest challenges?
So maybe we should talk a little bit about how to really think about the speed of light and why it matters so much in this context. So one of the, I think, best illustrations of the limits of the speed of light can be found in a very short YouTube video from Grace Hopper, where she talks about how she really couldn't internalize what a nanosecond was. And she went down to the IT department at or the engineering department, I guess, at the place where she was working, which I think was like some branch of the US military at the time. And she asked them, she tells us in kind of like a funny way, she asked them to give her something that could represent a nanosecond. And what they did was they cut a length of wire, which is the length of wire that the speed of that light could travel in a nanosecond. And that works out to be just under a foot. And the issue there is that, and let me switch from Grace Hopper language to metric because I'm Canadian, but that foot is okay.
I prefer the metric system anyway. Come on, man, it's good.
Okay,
we're all engineers here.
That foot is roughly 30 centimeters. So light can travel 30 centimeters distance in a nanosecond. What that means is that if you're on a different rack in a data center, like you're never going to be able to contact that other rack in a nanosecond. And of course, this is all like theoretical limits. Like this doesn't even speak to the amount of time you lose going through the whole network stack and the operating system and all of that. But definitely you can guarantee that you're not going to contact some other rack in a data center in a nanosecond. But when we scale this up, and metric is pretty cool for this, a microsecond is around 300 meters. It's like 1,000 times a nanosecond. And then a millisecond ends up being around 300 kilometers. So you can travel a distance of 300 kilometers in a millisecond if you're traveling at the speed of light. What that means is that if you need millisecond response time and you need to contact multiple servers, they have to be within that, well within that 300 kilometer radius, because you need to make a round trip to get there. And there's all sorts of issues there. Just one more thing to mention, which is that the distance between New York City and Paris is around 6,000 kilometers. So in theory, a one-way trip at the speed of light is around 20 milliseconds. Since you need to make round trips to do consensus algorithms, that's a minimum of 40 milliseconds. But then when you introduce network drag through the stack and everything, most cloud service providers from New York to Paris will take you around 90 milliseconds.
Yeah, I mean, there's relays going on, there's attenuation, there's a lot that, I mean, yeah, the pure raw number, sure. But in reality, go New York to Singapore, we're talking a long, long way. So, implementing a database where you're trying to get consistency across, like let's say, one person is accessing data in New York, another in Singapore at the same time, who wins is kind of one of these conversations we have, like same account, like, okay, like, that account data is living in three places. Maybe you have it in three places because you want to survive the failure of an entire country, you know what I mean? Like, or a cloud provider. These things are, they're very real, and they're tacit problems. They aren't theoretical by any means, right? And so when we start to think about the time it takes for a transaction to commit, and if you think about this as terms of, by the way, Adam, just to clarify, I think if people don't understand the concept of consensus versus synchronization, can you just talk about that a little bit? Because I think some people get, like, I remember, salespeople, I love salespeople. It's like, yeah, we synchronize data across three places. Like, we don't synchronize, man. We gain consensus, right? So can you just give a quick, like, the difference between those two things? It's actually pretty important.
Sure. So if I understand the question that you're getting at, synchronizing is really all of the data is being operated on in a single location. And once the transactions commit, then in the background, you're sending some data off to some replicas elsewhere, and they're being accessed there. But that's not the way Cockroach DB works. The way it works is we achieve consensus on all of the pieces of data that we're touching. So if you have a transaction that involves some data which is in North America and some data which is in Europe, then we need to run a consensus protocol on transaction commit, which ensures that the data is consistently managed across both of those sites. And the consensus algorithm that we use for this at a very low level is Raft. And then we built like our transaction model on top of that.
Yeah. It's just one of these things that I like to talk about Raft as much as possible, because I think anybody who's actually building distributed systems, knowing these things is actually really, really important. If anybody is interested in learning more about Raft, if you haven't seen it before, there's this website called The Secret Lives of Data. It gives this really nice graphical representation of it. I think it's one of the most clean kind of descriptions of the whole thing. It does work really well. So let's talk about speed of light and data and transactions, right? So like, what are the biggest challenges when we start thinking about transactions, Adam, when it comes to speed of light?
So the biggest issue is that for a transaction to commit where data is in two separate locations, you need to at least pay one single round trip between those two locations, one synchronous round trip between those two locations during that transaction, to ensure that it will be written consistently. And I was careful to use the word synchronous because at least the way Cockroach DB is designed, you could imagine saying, well, I'll just pay that round trip time after I commit. But the problem is, if you pay that round trip time after you commit, there's no guarantee that you will have consistency between those two sites, at least for the duration of the time between that message being sent. And if you end up on the other side sending a message and it turns out that someone else has updated that data in the interim, now you have like a consistency problem. So you have to pay this round trip cost on transaction commit. And that's really, like, if you want to boil it down to that, that's the beginning and end to the entire problem here. Is how do we ensure that we only pay the minimum number of round trips? Because you can imagine transaction protocols that are super chatty and sending messages back and forth the entire time and waiting on all of them to arrive before they continue. So there's ensuring the minimum number of round trips. But then the second is, how can we place data so that we don't need round trips at all in many cases where we're running transactions?
So keep the data physically close to where it needs to be, so you minimize the distance. So it comes back to, like, I think when we traditionally think about a database, we think about the logical model, right? I think about foreign keys, I think about, referential integrity and joins and like all that stuff. I think with distributed systems, you start to think about the physical nature as well, right? I mean, and that's really what it boils down to, right, Adam? So what does that mean for people who are just building regular applications? So, I mean, I think, within a database, yeah, it's kind of obvious there's a transaction. What does that mean for like kind of other systems?
Yeah, it's a good question. So it's certainly the case when you're designing your app that you probably don't want to think about these things. And so our goal is to make you think about them as little as possible.
Yeah.
But at the same time, you can't get away from thinking about them at all. And the reason I say that is because, imagine you're a company and you want to start some fitness tracking app. If you have your database in the United States and you start bringing on users in Europe and in Asia, like when they're either querying the database or sending their fitness updates to the database, they're going to have to travel to the US database to make their data whole. And you could solve the database problem, but you still have to solve the application problem. Like you're going to want your application endpoints to be as close to your users as possible. And so it's really like to solve this problem completely, there needs to be a collaboration between where your app is deployed and where your data resides. And then at a bare minimum, you want your application endpoints to be close to all of your users, but to achieve the best possible performance, you want the data also to be as close to those users as possible.
Right.
So I mean, sorry, go ahead.
Oh, go on, Adam, please.
I was just going to say, so the bottom line is it's not the type of thing that you can just say, we want a global app that's going to handle users all throughout the world and then throw your hands up as to how you're going to place your app in your data.
Right. And I think you're just relying on, services alone within a cloud provider may or may not do that. I think we'll talk a little bit more about serverless and what that means in this whole context a little bit later, Adam. I think that's a really kind of interesting vector to go down when we start thinking like that. But I don't think, everybody's there yet. But I think you do have to think about it from both your application compute side and the data as well. We often think about the data just because it's right in front of us. So what is, when you talk to, the people who are using Cockroach, why does this matter to them, Adam? Like this battle?
I think the reason it matters to them is because in the world we live in now, latency is king. Like the phones we have in our pocket are, 1,000 times more, have thousands of times more compute than, the computers that sent man to the moon. We're used to getting everything very quickly. And part of that, going back to what you were talking about in terms of Google, part of that is because these web scale companies have given us that reality. Like if you take your Gmail app and go to some other country and you start a new account there, like your data is going to be served locally. And so your response time is going to be really fast. And humans are just expecting that quality of service in all of their interactions with the internet right now. And so the customers that we talk to tell us that they need to get the latency as low as possible so that their customers can have the best possible experience.
Yeah. We talk about the 100 millisecond rule internally. Can you describe that rule, Adam? I think it's a really good kind of description of this problem, right?
Yeah. So I think the rule as it's stated is that anything that occurs within less than 100 milliseconds is interpreted by the human brain as being immediate. And that's really what people are looking for in their responses when they're, loading their Facebook page, when they're loading their Twitter feed, all of these things.
Yeah. And I think it's just so easy to just go to the next service if you want to. I think the first time I forget oh my gosh, I'm totally flaking on the person's name, but it's another one of these Google things. Like I think it was a team that was building Gmail had said, yeah, we have to have, under 100 millisecond latency, no matter where a person is on the planet for their email. Because if I waited longer than 100 milliseconds for a transaction to commit, say on a bank, I guess, okay, it's a tenth of a second. I would still think like I would have that moment of, oh my gosh, can you imagine waiting 2 seconds for something to get done?
Yeah. Yeah, I've worked with banking partners in the past, and I've been told by them that if their transactions don't, like if you go to a POS, a point of sale terminal in a store, and you swipe your card, if that transaction doesn't complete in something ridiculously small, like 30 milliseconds or 40 milliseconds, I think it might even be lower than that, then they interpret that as like something super bad going on in the back end, and they just cancel the transaction anyway. So that's why your transactions appear to be so fast, because the underlying infrastructure is finely tuned to ensure that that happens.
Yeah. So I want to go into kind of a little bit of what we've done inside the database to actually fight some of these things. Because I think, one thing, okay, there's Raft and there's distributed consensus, but that can take a long time if you have data living all over the planet. And so I think there's some things that we've done. There was a question here about AP versus CP databases. Adam, I'm going to come back to that at the end, because I think it's actually a pretty important point. I think this will actually, this part of the conversation will help lend to that as well. So what are some of the things that we've done here at Cockroach to kind of combat the speed a lot? Because look, dude, if we're going to get distributed consensus and I have a piece of data in Sydney, one in New York, one in London, okay, look, at one round trip, it's still going to take a lot of time, right? Like, so what are the things that we've done beyond, consensus and some of the original design of the database?
So there's, I would say, two main things that's worth talking about today. One is the fact that, as I mentioned earlier, we really want to ensure that when you're committing a transaction that spans multiple geographies, that we do as few round trips as possible. Yeah. And if you're interested, we have a great blog post that I'm sure you can link to on parallel commits that was written by Nathan Van Benschoten. And he talks about, in that blog post, about all of the changes we made to our transaction protocol to ensure that when we cross regions, that we do so with only one synchronous round trip in the vast majority of cases. And that's really what's going to allow you to have transactions that span regions that aren't ridiculously slow. And really have that transaction commit time be bounded by the distance between the two furthest nodes in your cluster. So that's the first thing. The second thing is, even if you want to leverage these parallel commits, you're still bound by the speed of light. And that's what we're here to talk about. And so one of the things we spent a really significant amount of time over the last 2 years figuring out is how we can allow customers to configure their databases in such a way that they have control over where they place the data, and place in a way that makes it easy to place data close to where it's going to be accessed. And the idea really is that there's no better way to avoid a round trip than to have the data where you want it and not have to go outside of that region to write to that data or to commit one of these transactions on that data.
So what are some of those kind of configurations, Adam? Like what does that look like?
Sure. So we have a few different configurations that we rely on. There's really only 3 different patterns that we're seeing customers asking for. The most simple pattern is customers who say, I know all of my users are going to be in a single region. So I want all of, even though I have a big cluster and lots of regions and data in that cluster spread out over a bunch of regions, I want all of the information for this table to be pinned to a given region. And we have this table type that's called regional tables. And that ensures that all of the data resides in a single region, and you can have extremely fast commits within that region. The second table pattern we have is where you have a single table, but you're going to have users spread out throughout the world accessing the data in that table. But all of those accesses are occurring from the region in which that user resides. So for example, you're Jim, you live in the US. All of the data that you're going to be interacting with, your personal data is going to be kept in the United States. And so then what we do is we take that table and we partition it so that we have a US partition for that data and maybe an EU partition for that data and an APAC partition for that data. And all of the European customers are going to be accessing the partition in Europe, and the APAC customers are going to be accessing the partition in APAC, and the US customers are going to be accessing the partitioning in the US. Now, I've dramatically oversimplified what we've done to make this happen under the covers, but we have a blog post that talks about the details of how difficult it was to build this out and how we have to tie this into all of the indexes that are created around the tables and all of that fanciness.
Yeah, the details of how Cockroach works, and it really comes down to how we store data. I think it's like ultimately, I think once you understand like the concept of keys and a KV store underneath what we do, all this makes a whole lot more sense. So if anybody's really interested, go into there's a couple of spots in our docs where you can actually get into more detail, like technically exactly what's going on. One of the things that I find very cool about this, Adam, so you talked about, look, we're in the US, we're in Europe, we're in APAC. What happens if we open up and say, I don't know, South Africa or Africa, right? Like, I'm leading the witness here, but, do you take the database down, add a region? How does that work with Cockroach?
Yeah, so the other thing that we built in the 21.1 release, which shipped last year, was the ability to add regions to a database. And when you add a region to a database that contains one of these partition tables, then in an entirely online fashion, we'll maybe I've gotten a little ahead of myself. So the way you first add a region to the database is you have to spin up some nodes in that region. Right. And you deploy the Cockroach binary and start it up on those nodes. One of the coolest things that I don't think we talk about enough here at Cockroach Labs is that when you do that and you start those nodes up in this new region, you don't have to do anything else. Those nodes connect to the database. They will rebalance the data if necessary. They will start participating in consensus. It's all of that is done automatically. And if you compare that to some other databases, it's a real treat to not have to do much intervention. But then, additionally, if you alter your database and add this new region that you've created to the database, then it will create a new partition for each of these tables that you have partitioned by region. We call these regional by row tables because each of the rows may be in a different region. It will create new partitions, and when new users start connecting to those nodes, their data will automatically be placed in that new region that you created.
Right. And correct me if I'm wrong, but the data that does live in, say the African data lived in, the sub-Saharan data lived in, EMEA servers, that would all eventually be moved as well, right, Adam?
Yeah. That's right. I mean, if you have data that for users that are in Africa and you create a new African region, that data actually has to be moved manually right now. But it's very easy to move it by just updating all of those rows with the region information. So it's like, it's not like a physical operation of like rebalancing your database or doing anything like that. It's really all handled through SQL, and you just update those individual records. And then the system will actually underneath the covers move their location.
Yeah, the physical movement of the data is completely automated in production without downtime, any of those things. I think, it's just kind of one of these things, having this kind of highly resilient database is kind of special and unique, but doing these sort of things, doing online schema changes, like there's so many things, like rolling upgrades is one of these things that's really cool within the context of Cockroach. Like, the whole kind of Cockroach name and not being able to kill it is a big deal. And I also, dude, I don't know about you, but I love talking about how we could just spin up nodes pointed at the cluster and it just rebalances everything. Like the ease at which we can scale horizontally is just unlike anything I've ever seen, and I don't limit scale within a single AZ or a single region. We could even do it across cloud providers. I was on with somebody from Form 3 earlier today. They have single logical database going across multiple different cloud providers, which I think is truly tremendous. So it's pretty awesome. So the regional stuff is interesting, Adam, and I think there's another use case for this kind of capability. And, when you start to tie data to locations, like I want all my German records to live in Germany, or I want, my UK records to live in the UK, I got US records, and it's correct me if I'm wrong, this is each table down to the row level, correct? That's right.
We have the ability to ensure that the data resides in those regions because they're partitioned that way.
That's right. That's right. And without any application logic or without any sort of like manual intervention from the DBA or any sort of like, I guess, heavy intervention, it's just all done automatically. And so, are people using this to do things like compliance as well? I mean, I think for the speed of light, yeah, it starts to make sense, right? Like get that data to live where the person is.
Yeah.
People using it for compliance as well.
We're starting to see people that are using it for compliance that have a desire to have their data reside in the location in which it's created. And they can create these tables. And we actually created in 21.2, which shipped just late last year, an ability to restrict data so that it doesn't move out of the region in which it's placed in regional by row tables. What I mean by that is we won't place it on disk outside of that region. If you query it, you still have the ability to query it from anywhere on the globe. And if you don't want that data to move outside of that region, even for queries, then you would have to restrict it somehow at the application layer.
So kind of a tangential or I guess adjacent question is, there's a lot of other things that happen in a database, Adam, beyond transactions. Talk to me about like backup and restore, and what does this mean for those type of capabilities as well, right? Because now we're talking about data that's living in regions. How does this affect that as well? Are we, what are the changes or the different ways of thinking?
So what's cool about what we've built is that when the data is backed up and restored into another cluster, provided that it has the same regions, it'll get spread out to the same regions that it was in before. So all of this data is like preserved when you do your backup and restore. So yeah, the capabilities are really like woven through the entire stack.
Yeah. And I think once you become distributed, it's all the little things that actually have to be distributed as well. Like the backup and restore, we talk about, change data capture, and that's, distributed in the context of Cockroach. I think all of the abilities become this distributed kind of, or of this kind of distributed nature. So, yeah. So there's a couple questions here, and I'm going to get into the future here as well, Adam. But so we're talking about how do you set up these localities? What is the process for setting up the localities?
Yeah, it's a good question. I mean, it's not. Sometimes when you look at a system from the outside, you think, oh, all of this is magic, and then when you dig into it, you realize like there's only so much magic that we can do, and so we can't really tell which region a given node is in, because in many cases these are running on VMs, and there's so much that's abstracted away from us in the hardware. And so what we require users to do is to configure the locality of each of their nodes when they start them up. So when you start up a node, you say there's a locality flag, and you can set that flag to whatever you want, but typically customers set it to match the cloud service provider that they're in. So the locality flag will be, say, US East 1 if you're running in AWS's US East 1. And then if you want to set up some other nodes in some other geo, then you'll set that locality flag to match the location that those nodes are in. And that locality flag tells the system these nodes are in these locations, and then you can map them to regions right up through to the database.
Yeah, so it's pretty straightforward. You basically spin up a node and assign it to a region.
Yeah,
it's manual. It's not automatic yet, but I think it's getting there. So there was a question early on, Adam, about synchronization. How does this compare to document databases? Could we repurpose Cockroach to be used as a document store? So I guess at the heart of this is a little bit around the CAP theorem, and there's an AP database and there's a CP database. Can you just describe the differences between the two and kind of why one is different than the other?
Sure. So at a high level, an AP database favors availability over consistency.
Right.
And what that means is if you have some number of nodes that go down, it will continually accept data. As long as you can contact any node of the system, it will continue to accept data at the expense of knowing whether or not that data could eventually be committed. So for example, you could be trying to insert some values which conflict with other data that already exists in the database. And when the system comes fully back online and repairs itself, it realizes it can't commit that data. So that data will just be lost. But the bottom line is the system is always available as long as a single node can be contacted. On the CP side, it favors consistency over availability. And what that means is there are situations in which the system will, in an attempt to preserve the consistency of the data, which in the business we're in, consistency is really king, it will prevent you from making changes if it doesn't have enough of the components of the system available. Now, where I think this analogy kind of breaks down is I think there's this immediate assumption amongst people that, oh, Cockroach is a CP system, so that means it's not available.
Right.
But that's not at all what we're saying.
Not binary.
CP systems, right? CP systems can be designed to be very, very highly available by maintaining large numbers of replicas and ensuring that when parts of the cluster go down, that the rest of the cluster is still up and can operate. So it's not, like you say, it's not binary.
Yeah, and I think it's actually a really important point to understand those sort of things. There's like, yeah, is there some sort of 5 nines of availability you can get with one of these databases that are, geographically distributed and guaranteeing consistency? Well, yeah, it depends on how hard you want to work at it. And some of the things that we're talking about here, Adam, in terms of how and where you locate data actually helps with that as well, right? I mean, it's more than just latency, right? It's some of the, I think we're seeing that as well, right?
Yeah, that's exactly right. And one of the things that we built into the system is the ability to configure the survivability of the system.
Right.
In cases where you want all of your data close together, you can get extremely low latency by having the consensus achieved within the same rack or the same zone of a cloud service provider region. But if you want to ensure that the database can survive if that entire region goes down, then you need to spread your data out to multiple regions, and doing so has a latency penalty. And that's why we give customers the choice to tell us, do they want the absolute fastest possible transaction response time, or do they need the availability guarantees of, if US East 1 goes down, which it does from time to time, that their data will still be available because it's spread throughout other AWS regions, or like you said, GCP regions or Azure regions or wherever.
Yeah, I think it's just, to me, this is one of the biggest takeaways when we start thinking about distributed systems and, with the database or not. I mean, we're dealing with a database here, y'all. That's what we build. But even in your own applications, as anybody's building things, there's a trade-off of latency and resilience, flat out. There is a trade-off. And thinking about it at the granular level that's important to you and your application, I think is what's really important. For us, well, we allow you to configure that at the table level. So, table by table, you're thinking through what are my goals for resilience or latency that you're actually dealing with, which I think is one of those things it's a little bit of a paradigm shift when people find Cockroach to get their head around, so. Yeah,
it's a great point, because when you're looking at a database system, you think, I'm going to want this to survive anything. And the natural tendency was, then I'm just going to create nodes in all these regions and spread my data out as finely as possible. As widely as possible. But the issue there is you're going to very quickly hit these latency problems because you're having to contact all the regions in all of the transactions.
It's a paradigm shift, man. And it's one of these reasons why this distributed database, that is distributed SQL category, has kind of emerged. We're dealing with the physical nature of data now. This isn't just some synchronization between two locations, primary, secondary. I'm going to have a failover. It's not that legacy active passive. We're talking about active and that an active and being able to configure that down to the table level gets really, really interesting, and sorry, but sometimes a little complex when you go out and implement and think about it, but it's actually kind of fun and very powerful as well. So
yeah, I can certainly agree and say that I didn't anticipate how much time I would be spending at Cockroach looking at underwater cable maps for cloud service providers, but it matters. It matters if you're going around the Horn of Africa or if you're going straight through a continent.
That's right. It sure does. And you know what, y'all, it is underwater cables, by the way. Like Tonga was out for how long? Like it was, just a couple of weeks ago. It had, we had to build things in our database console and our DB console to show people, we have a map of the network latencies between each node within a system. And it's funny, when we created that, I think at first it's like, the longer the latency, we were actually putting them in red versus green. And it was like, wait, that doesn't make sense. It's not that it's red, it's just longer. You know what I mean? It's not bad. It's
Right.
just a practical reality is that there's a speed of light. And knowing that is actually pretty important when you start to deal with the distributed nature. So Adam, where does this all go? What are some of the things that are on the horizon for us around this kind of this multi-region? I know making it more simple was a big deal, and I know we're doing a lot of work. Where are we going with this?
So there's a few places in which we're going. One of them is that we want to beef up the capabilities we have around domiciling data and ensuring that it's located in the right place and making that as configurable as possible for customers who really require that. The other major area that we're eyeing in the future is the ability of taking all this great multi-region capabilities and giving it to the world for free, and doing that through our serverless offering, which is already free today, and allowing customers to leverage multi-region capabilities within the serverless construct.
Yeah. So okay, talk to me about that, because to me, serverless gets really, really. Once I saw serverless, I was a doubter of serverless until about 6 months ago. By the way, Adam, just in general, I was like, come on, really, And then I think once I really got it, I couldn't unsee it. It's one of those things.
Right.
When you talk about serverless, what do you mean, right? Like, I think let's just start there.
So at a high level, we've talked about how you need consensus in Cockroach DB. Consensus requires at least 3 nodes. Nodes in cloud service providers are not free. And really the way in which you need to structure your system so that you can provide a free service, and serverless is a free forever database service, is you need to stack in a bunch of tenants on a single cluster. And so you can create this larger cluster and you can put hundreds or thousands of tenants in a single one of these serverless clusters. And what I mean by tenants is when Jim opens up his account using his GitHub ID, he gets what looks like a cluster in this much larger serverless cluster. And when I do the same, I get a view of a cluster with guarantees that I'm not going to be seeing Jim's data. He won't see my data. We're not going to interact with each other or impact each other through CPU usage or memory usage or anything like that. So that's serverless in a nutshell. But what we want to do is take that serverless construct and make it multi-region aware. Multi-region introduces additional cost complexities because ideally you're going to want to have 3 nodes in each of the regions in which you reside so that you can achieve consensus locally. So now you're talking in a 3-region cluster of 9 nodes. And now it starts to get really expensive or more expensive. And so serverless allows us to pack a whole bunch of tenants in one of these clusters and then make them very, very inexpensive to customers, so much so that we can give them away for free.
Yeah. And then when we get, right now, y'all, serverless is a beta, and it, one of the big reasons we call it a beta is because it is single region. And, the pure vision of Cockroach is, it's this global database. I think it's kind of interesting. Oh, by the way, I also put a link into the chat for, there's a great blog post on how we built the serverless database by Andy Kimball, who's one of your peers. He's another amazing engineer working on databases for a long time. I'm sure you guys' conversations are great. But I think when we do get to multi-region, when you start to become serverless, and you don't have controls, or you don't the concept of serverless being, I don't know which node is which. I don't know anymore, right? And so the complexities of going multi-region to locate data, Adam, I presume are going to be pretty intense, right? What are we looking at to solve those sort of things, right?
Well, the good news is the serverless is built on top of the Cockroach DB stack, which has been handling multi-region for a long time. I don't want to say that there's not challenges in bringing serverless multi-region capabilities to serverless, but we've solved all of the very difficult problems all of the most difficult problems already. And really it's about fine-tuning things so that the multi-region capabilities are exposed through tenants and are able to be leveraged in such a way that makes sense in a serverless environment.
Yeah. I'm going to argue that, you can't really be a serverless data, because to me, serverless means more than just not servers. It means I don't want to deal with load balancers. I don't want to deal with regions. I don't want to deal with, like, literally, if I'm a developer, I want a single endpoint. Like I just want a SQL API in the cloud. I want an endpoint. I want to code against it. Don't make me think about these things. And I think abstracting that away into this simplicity, making it multi-region, not easy. I don't think you can do it unless you have some of the capabilities that are in Cockroach DB. Honestly, like I said, the more and more I thought about it, the more and more it's like, yep, there's this distributed database and then there's a serverless database. I think one is dependent on the other.
Well, it's like that analogy I was talking about with the single file on disk as a database. Like there's lots of things you can do in the world, but they're not going to work. So it's true that you could set up a multi-region database in some trivial way, but getting it to perform, getting it to be consistent, getting it to really meet the requirements of even rudimentary application developers requires a bunch of sophistication that we've already built into our product.
Yeah. I think you just named my biography. You could do it a lot of different ways. It doesn't mean it's going to work. Somewhere in there, Adam, I kind of dug that. So, but it is interesting. I think there's some really kind of interesting kind of concepts that we're going to see in database development over the next 5 to 10 years that really change the way that we think about data. Like I'm an absolute firm believer that we can get to the point where there's a SQL API. You just have endpoints in 7 parts of the world or whatever it's going to be, each continent, whatever it's going to be, and you're going to be guaranteed sub whatever millisecond access to that data. I mean, I believe that's possible. Do you believe that's a possibility, Adam?
I think that it's more than a possibility. I think it's a certainty that this nut will be cracked soon. And I think that we will crack it, but if we don't, someone else will, because it's such a pressing need in the market for this kind of capabilities. One thing I'll add to that is that I think that what's interesting is that these problems keep arising and keep getting solved by the database industry. When I first joined it, like more than 20 years ago, I thought all the problems in this industry were solved. But we're just finding new and more interesting ways to deploy database systems that are uncovering a whole bunch of tricky and difficult problems. And we're always looking for good people that come help us solve them.
Yeah. Well, that was a perfect bookend. I couldn't have designed it any better, Adam. And it is. And there's some amazing, difficult software engineering problems that are being worked on across the planet in lots of different ways. And so I find them to get really interesting when you start to deal with the physical limits of our world. Because we don't have quantum computing yet. You know what I mean? Like we aren't at a point where we're doing some fundamentally different set of compute, right? We're running into the speed of light. And solving these problems to me, and honestly, talking about these problems is fun for me, Adam.
I agree.
I think it's in all aspects, and I think Cockroach has been an amazing place for me over the past 3 years, almost 4 now. Gosh, oh my God, I can't believe it. Just because the pure intellectual stimulation of some of these problems and how do you actually talk about it? This is not simple stuff.
Yeah,
and so I think
agree.
Yeah, I mean, there's one thing to talk about it, but there's whole the other thing to code it. So kudos to you and the team, because I think it's just truly phenomenal work and actually very, very important. So
thank you.
Well, cool. Well, thank you, Adam.
It's my pleasure. It's always great chatting with you, Jim.
Yeah, and likewise, Adam. So, but thanks everybody for joining as well. It really does mean a lot to us that you take time out of your day to enjoy some of these conversations. I hope it was valuable. We definitely endeavor to make to get information out there to help people understand how these things work. And hopefully you can take something away and figure out how it might apply to something you're building today. For us, I think we're all pushing limits. It'll be really interesting to see some of the things that get innovated and the breakthroughs that happen over the next couple of years. So I'm looking forward to seeing all of it. So, all right then. Well, Adam, enjoy. I don't know how you say goodbye in Canada. I think it's just goodbye, right?
Yeah, pretty much.
Toronto, Chicago. Come on, man. They're similar cities, buddy.
Yeah.
So,
they are.
And we both have an original. What's that?
Nope, I'm good.
Yeah, and we both have an original 6 hockey team. I'm just going to leave it at that. But all right. Thank you, everybody, for taking the time today. Thank you, Adam.